Water is the fundamental ingredient for life on Earth. Looking at our Earth from space, there is abundance of water for our usage. However, only a small portion of Earth water is accessible for our needs. How much fresh water exists and where is it stored? The quality of water affects all of us. Water pollution is one of the most serious ecological threats we ever face today. Due to the increasing of water pollution, research needs to be performed to determine the level of water cleanliness before it can be used. There are some known methods to assess the water quality, such as manually collect the water sample. This method requires the researcher to collect the water sample by hand at the location, transport it back to the laboratory to be tested using specific equipment. Another method is to bring the equipment itself to the location, gaining results in a shorter time. Both methods require the researcher to be present at the water collecting point. These two methods give major problems if the coverage area to be tested is very large. For example, the water surface area for Tasik Kenyer is 260 km squared. For such a large area, the water quality for the left side and the right side might be different. To overcome this problem, we have come up with an idea, which is Mobility Buoy for Water Quality Assessment in Real-Time Data, or a 3HS buoy. Using the 3HS buoy, depending on the GSM communication signal availability, a researcher or user is able to assess the water quality remotely in real time from the office or even from the lab without having to be present at the water collecting point. Upon receiving a coordinate from the user, the 3HS buoy can move to the given point, measure the water quality, and send back the results to the researcher wirelessly via GSM connection. This means that the buoy is able to cover the whole water surface area. HS is programmed with self-mobility positioning system using GPS, which enable the buoy to move to any location instructed. Constant calculation of positioning enables the buoy to start at one location, and even if it is drifted away, the 3HS buoy will rotate and move back to the last instructed location. 3HS buoy was designed with lightweight materials, so the function of portability can be achieved. The buoy is equipped with high-efficiency solar panel to recharge the 2 units onboard batteries. The system will measure the voltage level of each battery. The battery with higher voltage level will supply power to the system, whereas the other battery will be recharged. The 3HS buoy has been tested at 2 locations. The first one is at the pool of University Technology Mara Shah Alam Chancellery. The results are as follows. Each of the 5 red markers indicates the locations that the buoy has already reached. The second location is at the lake of Section 2 Shah Alam. The results were compared with the Water Quality Guide, which is the national water quality standards for Malaysia, to test its viability. The novelty for this 3HS buoy is that it reduces labor costs, robust, energy saving, and also contribute to the green technology.